Okay, so I'm going to separate it now. I decided to chop that off in case this takes a bit of time. Okay, so it says, suppose the logistic differential equation models the number of DVD players in U.S. homes where P is in millions of players and T represents the numbers of years since 2000. And that's it. So what this tells us, by the way, is the carrying capacity is 200, so it's 200 million. Okay, so what is the limit as P of T, which we don't know what it is, goes to infinity? Well, it goes to the carrying capacity, because remember our graph approaches the carrying capacity, so it equals 200 million if we follow our units. Okay? And then also, what is the limit of the rate of change? Well, if you look at the slope, it eventually becomes 0. Any exponential eventually becomes 0. Okay? And now it says at what value of P will P prime of T reach its maximum value? Well, that's right there. It's at the carrying capacity, and it's halfway the carrying capacity. So when will that happen? Well, it's half of this. So it's at 100 million is when it will reach, when the slope will be the greatest, because it's actually at the inflection point. Okay? All right, so now what we're going to do is we are going to integrate this. So I'm going to start with this, and I'm going to separate it right off the start. So I'm going to bring all of this over here and bring the dt over there. So I'm going to get dp over p times 200 minus p is equal to 0.000120. I guess I don't need that 0, dt. So I need to integrate both sides. Now we're going to do our side work because we have to use partial fractions here. So this becomes 1 over p times 200 minus p is equal to a over p plus b over some 200 minus p. Okay? So when I cross multiply, I get 1 is equal to a times 200 minus p plus b times p. Okay? So I have some convenient values I'm going to use. It's really where this is undefined. And that's going to be when p is 0 and when p is 200. So when p is 0, then I get a is equal to 1 over 200. When p is 200, this is gone, and I get 1 is equal to 200p, or b is also equal to 1 over 200. Okay? So what we're going to do is we are going to now say that the left side is the integral of 1 over 200 over p plus the integral of plus 1 over 200 over 200 minus p, and then I have a dp there, equals the antiderivative of the other side, which is 0.00012 dt. I'm going to drop off that last 0. Okay, so when I integrate this, this is just 1 over 200 natural log the absolute value of p. And then this one, since p is negative, it's negative 1 over 200 natural log the absolute value of 200 minus p is equal to, when I integrate that, I get 0.00012 t plus some constant. Okay, so now we got to combine these. So I get 1 over 200 natural log of the positive 1, which is p over 200 minus p, equals 0.0012 t plus c. Oop, drop to 0. All right. Simplest way to handle this now is let's get rid of that 200. So I get the natural log of the absolute value of p over 200 minus p is equal to, well, when I multiply by 200, I get rid of 2 of the zeros and I double that. So that's going to be 0.024t plus c. And when I multiply this by a constant, it's still just a stinking constant. Okay? All right, so now let's go ahead and e both sides. So I get p over 200 minus p. And since this is always positive, it stays the same. When I e the other side, I get ce to the 0.024t. Okay. Now, because we can't separate a denominator, we're going to flip both sides. When I flip this side, if I flip this, it just becomes 1 over this, which is e to the negative 0.024t. But that's still just a constant. It's 1 over that, so that 1 over c is still just a what? Constant. So it becomes ce to the negative 0.24t, 024t, is equal to, when I flip this, I get 200 minus p over p. Okay, so I'm going to go rewrite it up on the top here. So I get 200 minus p over p is equal to ce to the negative 0.024t. All right, now if you look at that, I can split this up, and I get 200 over p minus 1 equals ce to the negative 0.024t. All right, I'm going to add 1 to both sides. So I get 200 over p is equal to 1 plus ce to the negative 0.024t. Now essentially I'm going to just cross multiply and end up switching these two. Multiply by p and then divide by this one. So I get 200 over 1 plus ce to the negative 0.024t is equal to p. Well, and if you remember from before, how do we compute c? And we know that our c value is equal to our carrying capacity minus our initial amount divided by our initial amount. Okay, so if we finish this one out, our c, based upon what we said, is our carrying capacity was 200, and our initial value here at 0 was 2. Okay? Because remember, this is the relative start. This is how much it changed relative to the start. So I get 198 over 2, which is 99. So my equation is going to be p is equal to 200 over 1 plus 99 e to the negative 0.024t. All right. So we did this part. The last thing we have to do is, if the market is saturated with 90% of the households have a DVD player, when does this occur? Oh, we didn't do when it's 2013. I'm sorry. So if you look here, it's number of years since 2000. So how many will there be in 2013 was the question. So we have to plug in 13. So P of 13 is going to be 200 over 1 plus 99 e to the negative 0.024 times 13. And if I go ahead and compute that, I hope you can see that. Yep. I get 200 divided by 1 plus 99 e to the negative 0.24 times 13. Close that one, close that one. Okay, so I went through and rechecked it, and I'm believing I haven't made a mistake here. So after 13 years, there are only 2.72 million in here. So I think the way I wrote the problem, there may be an issue with the growth rate. Maybe I put an extra 0 on there that I shouldn't have. But anyway, so it's growing pretty slowly, which is not very realistic. So anyway, so that's what P of 13 is. The other one is when. Part C says, when will the market is considered saturated when 90% of the households have a DVD player? What year does this occur? Well, saturation would mean you have 200 times 90%. We're going to set that equal to our function. e to the negative 0.024t. Okay, and I did that. So I did a solve. So I did, just so you can see the mechanics of this. I did 90 times 0.200 and set that equal to it, and then I put the solve out front. So I did 90 times 200 set equal the function, and then I went back down here and said solve it for t, and lo and behold, I got 283 years, which is obviously a problem, that means that would happen in year 2283, which we all know DVDs will be long gone and dead by that time. So anyway, that works out to be 283 years, which does not make a lot of sense, but it's really the mechanics of going through it. I think what happened is I need to make an adjustment up here. I probably should have cropped off a 0, and it would have affected the growth rate, so we reached it a little bit faster. So anyway, just wanted to run through one of these. I hope this was helpful to people, and I will see you all on Tuesday, so make sure you read 8.1 and 8.2. So thanks. Bye-bye.